Next, functional isomerism. So functional isomerism, that is due to the difference in functional groups. Compounds having same molecular formula but differ in the nature of functional group present in it. Okay. So functional group isomerism or functional isomerism. This is due to difference in the functional group. Okay. So compounds with molecular formula differs in the functional group. They are functional isomers and that phenomenon is functional isomerism. So generally alcohols are functional isomers of ethers. Okay. So first kind of functional isomers, alcohols and ethers. For example, ethyl alcohol and dimethyl ether. Okay. Aldehydes are functional isomers with ketones. Okay. So aldehydes and ketones both are functional isomers. Carboxylic acids and esters. Okay. So here aldehydes, propanaldehyde, acetone both are functional isomers. Then carboxylic acids are functional isomer of esters. Okay. So carboxylic acids and esters both are functional isomers. For example, acetic acid. Okay. They are functional isomers of methyl formate. Okay. So cyanides and isocyanides both are functional isomers. Okay. Cyanides and isocyanides both are functional isomers. So methyl cyanide, methyl isocyanide. Then nitroalkanes and alkyl nitrites both are functional isomers. So nitroalkanes and alkyl nitrites are functional isomers. Then coming to alkadienes and alkynes. Okay. Alkadienes and alkynes. Alkadienes and alkynes both are functional isomers. So 1,3 butadiene. Alkadiene, diene, 2 double bonds. They are functional isomers with the butane. Okay. Alkyne. Next, primary, secondary, tertiary amines. These are functional isomers. So this is primary amine, nitrogen linked with single carbon. So 1 amino propane. This is primary. Okay. And this is secondary amine. So here nitrogen linked with 2 carbon atoms. So N-methyl amino ethane. Nitrogen linked with 3 carbon. This is tertiary amine. N, N dimethyl amino methane. So all these are functional isomers. Okay. Then glucose and fructose. Glucose and fructose. These are also functional isomers. Glucose, that is aldohexose, aldehyde functional group. Okay. And fructose, ketohexose. It contains ketone functional group. Okay. So all these are functional isomers. Next, coming to metamerism. Next type of isomerism is metamerism. So metamerism, that is due to the difference in the linkage of substituent groups to the functional group. It arises due to the difference in the linkage of substituent group to the functional group. Okay. So compounds having same molecular formula. But here they differs in the linkage of substituent groups to the main group. Okay. So this is due to difference in the linkage of substituent groups to the main functional group. Okay. So generally metamerism is shown by ethers, ketones, amines. Okay. So different examples are there. Coming to ethers. Okay. For example, diethyl ether. So this is also called as ethoxyethane. Diethyl ether. Having general formula C4H10O. So this is the general formula of diethyl ether. So this is ethoxyethane. Metamer of diethyl ether. So this is metamer. Methoxypropane. Okay? Methoxypropane. So methoxypropane. This is also called as 1-methoxypropane. 1-methoxypropane. And one more functional isomer is also there. So that is 2-methoxypropane. Okay? Okay? So here, starting from, numbering from here, 1, 2, 3. So this is long chain. Okay? First carbon linked with the methoxy group. So 1-methoxy. Okay? And here starting from numbering here, 1, 2, 3. So second carbon is linked with the methoxy group. So 2-methoxypropane. Okay? So all these are having same molecular formula, but differ in the linkage of, nature of linkage of substituent group to the main functional group. What is main functional group here? Oxygen. Ethereal oxygen is main functional group. Okay? And one more example, ketones. So next type of metamerism, that is shown by ketones. For example, ketones having general formula C5H10O is there. It shows two types of metamers. One is diethyl ketone. This is also known as 3-pentanone. Okay, so this is 3-pentanone. And methyl N-propyl ketone. So this is 2-pentanone. Okay, 3-pentanone, 2-pentanone. Both are having same molecular formula, but differ in the linkage of substituent group to the main functional group. Main functional group here is C double bond O functional group. In 3-pentanone diethyl ketone, 2 ethyl groups are linked with the functional group. And here 1 methyl and 1 propyl group is linked with the functional group. So these are also metamers. Next last, coming to ring chain isomerism. Okay. So here compounds having same molecular formula, but one having the open chain structure and other one having the ring form. Okay. So this type of isomerism is ring chain isomerism. Okay. So compounds with the same molecular formula differs in the structures in a such a manner, one having open chain and other having ring structure. Okay, and always these are functional isomers. Ring chain isomers are always functional isomers. Okay, so for example here 1-butane. So 1-butane alkyne. Okay, So this is functional isomer of cyclobutene, cycloalkene, alkyne cycloalkene. Okay. Then this is alcohol. Okay. Prop 2-in-1-ol. Okay. So this is isomer with cyclic ether. So here cyclic ether is oxetane. Okay. This is oxetane, cyclic ether. So alcohol with ether. Then this is propene. Propene, alkene with a cycloalkane, cyclopropane. Alkenes are ring chain isomers with cycloalkanes. Okay. So one having the straight structure. Okay. Open chain structure. Okay. And another isomer always having the cyclic structure, which are functional isomers. So this type of isomerism is called ring chain isomerism. So all these are different structural isomers. Okay.